Hi, I'm Toby. I'm from the Illinois River Biological Station. I just started as the IRBS's Emiquon program coordinator to monitor the fish and the vegetation at the Emiquon Preserve last year. And I was asked to talk about the submerged vegetation data that we have for Emiquon, which goes back to 2008 and continues to the present day. And so I'm going to give you a summary of the monitoring data that we have, looking at the density of aquatic vegetation, where it's found, and also at the species composition that we see over time in the lake. First off, it's important to note that this is a tale of two methods. Originally, the vegetation was sampled using the LTRM rake method, which you can see here. This rake is tossed and pulled back with the vegetation that's on it, and that was performed from 2008 through 2015. After that, a box sampler method was employed. The rake sampler was able to cover a lot of ground rather quickly, it seems, and so a lot of sites were able to be visited and a lot of samples pulled. But one of the cons is the estimate of actual biomass is a little bit, it's based on some relationships and was questionable at the time. And so they switched to a box sampler, which gets exactly a 1 meter square area. And the samples are taken back to the lab and their exact dry weight is measured, and you have the opportunity in the lab to look at IDs a little bit more carefully. And so for those reasons, that change was made to the data set. So first, the LTRM rake method, again, 2008 to 2015. What occurs here is a water quality parameters recorded from each site. 6 casts are made around the boat. Each cast is supposed to be a specific area, and the total density of all the vegetation on the rake head is recorded, and also the density for each species present on the rake head, which is identified right there in the field. The densities are based on some notches on the vertical portion of the rake teeth as they're held the way they're being held in this picture on the left here, and based on the number of notches that are covered, a score is assessed, and that's supposed to be a percent coverage. And yeah, this was conducted actually every month from May to September during this time period. But for the purpose of the analysis I'm showing you today, I restricted the data set that I'm using to just July and August, and I took the averages within those months and then re-averaged them against each other. That's just because with the box sampler, we've only been sampling during August or sometimes July, and that allows us to compare more closely. With the box sampler, again, we sample in August and July. I didn't actually have a great picture of a box sampler, so I've got you a picture of a metal box. But here's a picture of the actual box sampler in the boat, and you can see it's just a metal box, 1 meter square. It's got floats on top, and at the bottom there's a plate that slices off the roots of the plants, and that allows us to pull off all the plants within that 1 meter square area, and take them back without their roots. Again, water quality parameters are collected. There's a visual ID in the field of what's around the boat, and then there's that sample taken back to the lab, which is frozen, and then later it's identified to each species, sorted by them, and then wet weights are taken by species, and then they're dried, and dry weights are taken by species. Yeah, and here's a picture of what that sorting looks like in the lab. So there's a chance to see, and I got a spread of most of the species that we saw this year in this photo here. You see some American pondweed, coontail. I don't think there's milfoil in this picture. might be there. And then there's, I think we had some small pondweed and some water star grass. Okay. So I want to look at some trends in biomass per area. Obviously, it can vary quite a bit. Here's some pretty thick stuff on this rake. And actually, in the rake system, there you're recording a score in the field, but that can actually be converted to a biomass value if you average all the rake values around the boat for all the veg. There's a conversion to the estimated biomass. I honestly actually don't know what units it's in, but it's obviously biomass, so it's giving us something a little bit more relevant in terms of its index scale. Here's the average rake score in those months, June and July from 2008 to 2015 with that, and then this is it converted to biomass. Again, I don't really fully understand what these units actually are, but there's some kind of biomass per area, and so whatever their absolute value is, we're getting a relative sense of how that's changing over time. The clear thing I see here is an increase from 2009 to 2010, and then some steadiness in the data from 2012 onwards. Possibly a decline, possibly 2010 is just a peak. I know in a different way of looking at how to average those rake values across different sites and seasons that Doug was looking at and that we were talking about together earlier. You still see this increase, and you see that sort of more stable value from 2012 onwards, but there's that stable value is more similar to the 2010 value. But yeah, overall, lots of veg doing pretty well during this time period. Here's the dry biomass per square meter based on the rake values. You can see generally steady values, maybe a slight decline over time. Now, there's a fairly high value in 22 compared to 21, so either 21's low or 22's high. I was talking with Doug about this, and he had actually brought this up, and what seemed to be the issue, and did in fact turn out to be the issue, is that some of our samples, it's been hard to find places where we can actually get vegetation samples during these drawdown years. And then last year there wasn't a drawdown, but there was still, as you heard from Andy, very limited extent of vegetation. There's also been fairly sparse vegetation, so the high value was surprising. And it turned out those high values were completely driven by the few times we ended up in a ditch, like on the north end of the lake. So here I've separated out this dashed line, shows you the density over time, the biomass over time per area in the ditches, and then the solid line is not in the ditches. And you can see a great difference there in 2022. So actually, if the part of the lake that TNC is interested in is mostly that open water area in Flag Lake or around the edges of Thompson Lake, that solid line is probably more representative of what's going on there in terms of the vegetation. There are some other years, it seems actually more consistent than I expected. I expected to see that difference bear out throughout the years, but I guess the density was still fairly high, even not in the ditch in other years. And maybe there may not have been quite as many in the ditch samples. I will say in 2022, the samples that were in ditches, I know they were in ditches. In previous years, I used some GIS magic to decide whether the site was probably in a ditch or not. So there's probably a few sites that are called in the ditch that are actually not in a ditch. And maybe a few the other way, probably not. So I don't know if that may be influencing what we see there. It does look like maybe the ditches actually had lower density in 2016. I don't know how much stock to put in that and how much that may be an artifact of that GIS process. But it seems a bigger difference than in some of the other years. Oh, and I did just actually run that comparison over GIS, whether a sample was taken from a ditch or not back in time, even during the rake time series. And again, that may or may not be terribly accurate, but it seems like those values are fairly consistent. If anything, maybe ditches had less abundance. I don't know if that's reflecting some of the deeper parts of ditches where maybe there wasn't as much vegetation, and maybe that's what's going on in 2016. But yeah, it seems relatively consistent. So that high value in 22 is unusual, but what seems more unusual about it is the really low values where vegetation is existing outside of the ditch. So I wanted to look at both of these data sets together, and obviously we had that sort of consistent abundance or high abundance in earlier years. We had a moderate or high abundance, and then followed by this recent lower values. There's really not much I can say here about how these compare. We never did. We don't have any data where those two methods are used in the same year. But if we, and so it's kind of tempting to say, what if? I don't really know how to compare this in any way that's rigorous. It's tempting to, and I'm going to here, but I probably shouldn't. But here we go. To put these two, 2016 and 2015, at the same amount, and then put the zeros at the same amount and see what happens. So I'm just going to stretch the figure on the left. And of course, you get something that looks like, maybe a long-term decline, probably not, maybe just a peak and then some steadiness and then a drop-off. What is clear is that the drop-off would be lower than even the earlier values and any of the values in the earlier time period. Again, I don't know how these things really compare. They're quite different methods, but it is perhaps mostly because folks who have been looking at this preserve over time have said this, but also this data seems to agree with it. The lower values in recent years are quite low. Again, these are not calculations of overall biomass. Those are calculations of just biomass where there is veg. So I'll switch gears here and look at species compositions. Several different species present in the data sets, and so we'll take a look at what we see. Here's a spread of data showing all the different species present in the rake data set that are submerged vegetation. So this is kind of, these are figures, but it's kind of like a table of figures. So I'm going to take a table approach of highlighting some of these as I talk to them. So first of all, there's a bunch that are kind of not often occurring or occurring at very low levels. So we've got chara, Illinois pondweed, primrose, typha, and water stargrass. Then we have several species that are present in most of the years and usually to some moderate or high level of abundance. We have the pondweeds, American pondweed, curly-leaf pondweed, leafy pondweed, and sago pondweed. There's coontail and milfoil, Canadian waterweed, and slender and southern water nymph. Okay, now transitioning over to time period of the box sampling from 2016 to 2022. Again, we have several species that were encountered only in a few years and or not very high abundances. These include the algae, brittle water nymph, Canadian waterweed, sometimes duckweed was noted as present, short spike milfoil, small pondweed, and southern water nymph. Of course, we also saw taxa which were abundant, or at least present in most years, including American pondweed and sago pondweed, coontail, milfoil, and water stargrass wasn't particularly abundant, but it seemed to keep occurring in several years. One thing that it's important to note about this is, as mentioned in the earlier when looking at densities, is that densities were different, particularly in the last year in 2022 and somewhat in 2016, between ditches and other parts of the lake. So just want to highlight how that works for these particular plants. American pondweed, coontail, and milfoil, much more abundant in ditches than in the rest of the system. Water stargrass only found in ditches, as well as milfoil. Of course, sago, although it's present in most of these years, seems to be on the decline and also not present in 2022. Of course, that's visible with ditches or without. What I'd like to do next is compare what was present before in the rake method to what's being seen now and get a sense of the major players over the long haul, and also what's happening to some of the changes in the abundances. So here we have the last stage of those two plots I was showing. So we've got the rake on the left and the box on the right. The grayed out taxa are the ones that were not very present in that time period, and the other ones are the ones that were present. That's overall grayed out, so let's take a look here. First, just want to highlight water stargrass. Water stargrass was not very abundant or present originally, but it became, it continues to keep coming up, so it seems to have stuck around. It's still at fairly low abundances all around. Then we have several which occurred in the earlier time period, which seem to occur fairly commonly and at moderate to low abundances, but which now are either not even detected or are detected rarely and at low abundances. So this includes Canadian waterweed, curly-leaf pondweed, leafy pondweed, and slender and southern water nymph. Some of those were already declining, perhaps Canadian waterweed and southern water nymph, but yeah, not found anymore. Then we have the four present taxa of submerged aquatic vegetation in Emiquon, which are present in every year and typically at a moderate or high abundance. American pondweed, coontail, and milfoil, and then sago, which was present moderately through most of the years, although declining in the last several years and not noticed in our surveys last year. So in conclusion, Emiquon's submerged aquatic vegetation density has been fairly stable and abundant throughout a lot of the time period, but it's been low in 21 and 22. Again, this is not talking about spatial extent. This is just the density where it occurs. In 2022, density was higher in the ditches, which we did sample. So we need to think about how sampling of ditches and other parts of the lake represent what is going on in the whole ecosystem. Also, as far as species composition goes, there's consistently four major players: the American pondweed, coontail, Eurasian milfoil, and sago, although that's been possibly declined in the last several years. Consistently present at low densities is water stargrass. We did see that even last year. And then several that have pretty much declined already in previous years is Canadian waterweed, curly-leaf pondweed, leafy pondweed, and the water nymphs. And of course, there's several other species that have been noticed occasionally at different times. Those that have declined, it's not to say they couldn't possibly come back, but that's just where things are at. Of course, none of this would be possible without help from co-authors, funding, and a place to do the work. So thank you to co-authors, especially Andy and Amber, for helping me get my feet oriented to the task at hand with vegetation sampling at Emiquon and others. Thanks to Jim for mentoring and helping me through lots of different things here at the field station as I start up, and had several conversations with Doug to be thinking about vegetation here at the fields at the site. And of course, I'm thankful to the Illinois River Biological Station and the Nature Conservancy for all the support. That's it. Thank you. Any questions?